10th CBSE Mathematics Chapter Probability. After watching this video, you will be able to understand elementary and complementary events. You will be able to understand an impossible and sure or certain event. Let us now find the probability of choosing a vowel from the alphabet. We know that A, E, I, O, U are the vowels. So the probability of choosing a vowel from the alphabet will be equal to, the favorable outcomes here is 1, 2, 3, 4 and 5, and all possible outcomes we know as 26 because there are 26 alphabet. Let us make 5 identical cards, and on it let us write the vowels A, E, I, O, U. We will put these vowels in a box and mix them, and then we draw a card from the box. What is the probability that the card has the vowel A? Favorable outcome here is 1, and all possible outcome here is 1, 2, 3, 4 and 5. Similarly, the probability of drawing an E is 1 by 5. The probability of drawing a U is 1 by 5. The probability of drawing an I is 1 by 5. Probability of drawing an O is 1 by 5. Now here we can see that all the events have only one outcome, and hence these are called as elementary events. If we add PA plus PE plus PU plus PI plus PO, then we get 1 by 5 plus 1 by 5 plus 1 by 5 plus 1 by 5 plus 1 by 5, which is equal to 5 by 5, which is also equal to 1. So the sum of probabilities of all the elementary events of the experiment is 1. A die is thrown once. Let us find the probability of getting factors of 6 on the die. Let us also calculate the probability of not getting factors of 6 on the die. When we have to calculate the probability of an event, we have to find the number of outcomes favorable to the event E by the number of all possible outcomes. When the dice is thrown once, we know that all possible outcomes is 6. Let us find the probability of getting factors of 6. Now 6 can be written as 1 into 6 and 2 into 3. So the factors of 6 are 1, 2, 3 and 6. Let us take this as event E. So probability of the event E is equal to, now we have found the favorable outcomes. The favorable outcomes here is 1, 2, 3 and 4. All possible outcomes is 6. Simplifying, we get this probability as 2 by 3. Let us find the probability of not getting factors of 6. For this, between 1 and 6, we know that only 4 and 5 are the numbers that are not factors of 6. So the favorable outcomes here is 2. All possible outcomes is 6. Simplifying, we get this as 1 by 3. Let us take this event as F, and so this will be probability of the event F. We can see that the outcomes of E are 1, 2, 3 and 6. The outcomes of F are 4 and 5. So the outcomes of E are not the outcomes of F, and the outcomes of F are not the outcomes of E. When we add all the outcomes of E and F, we get all possible outcomes, which is 6. Hence, we can say that E and F are complementary events. We can write F as not E. Now, let us add the probability of E and the probability of not E. Probability of E we have found as 2 by 3. Probability of not E is 1 by 3. Adding, we get 3 by 3, which is equal to 1. So we can say that the probability of E and probability of not E is equal to 1. We can use this relationship to find the probability of not E. If we have the probability of E as 2 by 3, and let us find the probability of not E. So we get probability of not E as equal to 1 minus 2 by 3, which is equal to 1 by 3. So we can use this relationship and find the probability of not E, or we can use the probability formula and find the probability of not E. Let us understand what is the range of probability. When we roll a 6-face dice, the outcome will be 1, 2, 3, 4, 5 or 6. Let us now find the probability of getting a 8 on a 6-face dice. The probability of getting an 8 is equal to number of outcomes favorable upon number of all possible outcomes. Since no face of the dice is marked 8, so the number of favorable outcomes is 0. All possible outcomes we know as 6, so the probability of getting a 8 is equal to 0. The probability of an event which is impossible to occur is 0, and this event is called as an impossible event. Let us now find the probability of getting a number less than 7 on a 6-face dice in a single throw. So the probability will be equal to number of outcomes favorable upon number of all possible outcomes. Since every face of the dice is marked 1, 2, 3, 4, 5 or 6, and all these numbers are less than 7, so we will surely get a number less than 7 when we throw the dice once. So the favorable outcomes is 6, all possible outcomes is 6, so the probability of getting a number less than 7 is equal to 1. So the probability of an event which is sure to occur is 1. Such an event is called as a sure or certain event. Probability always will lie between 0 and 1. Let us solve this example where a girl drops a coin at random on the rectangular region. The length and the breadth of the rectangular region is 3 meters and 2 meters respectively. We have to find the probability that the coin will land inside a circle of 84 centimeters diameter. Let us see the data that is given to us. It is given to us that for the rectangle, the length is equal to 3 meters and the breadth is equal to 2 meters. It is also given to us that for the circle, the diameter is equal to 84 centimeters. Because we have to find the probability that the coin will land inside the circle, we have to find the area of the circle and the area of the rectangle and divide them. Let us first find the area of the rectangle. Area of the rectangle is given by length into breadth, which is equal to 3 into 2, which is equal to 6 meters square. Let us now find the area of the circle. Area of the circle is given by pi r square. We know that the diameter is 84 centimeters. That means the radius equal to diameter divided by 2. So it is 84 divided by 2, which is equal to 42 centimeters. Since we can see that the length and the breadth of the rectangle is in meters, let us convert the radius, which is in centimeters, to meters. 42 centimeters will be written as 42 divided by 100, which is equal to 0.42 meters. Now let us find the area. So area equal to 22 by 7 into 0.42 into 0.42. Let us simplify this. We get 22 into 0.06 into 0.42. Let us not multiply this, as we are going to find the probability, for which we will be dividing the area of the circle and the area of the rectangle. Let us now find the probability that the coin lands inside the circle. So the probability that the coin lands inside the circle is given by area of the circle upon area of the rectangle. Area of the circle we found as 22 into 0.06 into 0.42. Area of the rectangle is 6 meters square. So simplifying this, we get 22 into 0.01 into 0.42, which is equal to 0.0924. Hence the probability that the coin lands inside the circle is 0.0924. After watching this video, you will understand elementary and complementary event. Some of the probabilities of all the elementary events of an experiment is 1. Probability of a sure event or a certain event is 1, and the probability of impossible event is 0.